Okay, today we're going to look at still finding the derivative, so still the rule for the gradient of functions, but we're going to use this thing called the chain rule. So if you have a look at our example here, it says find the derivative of y equals 3x plus 4 to the power of 20. Now, there's no way we know how to expand that out. That would be forever. So if we don't have our calculators and we need to find the derivative, what we're going to do is we're going to let inside the brackets, so let u equal what's inside the brackets, so 3x plus 4. And then I could therefore, if I'm saying that's 3x plus 4, I could write y could be considered as u to the power of 20. So then if you look up at that rule, it's saying that dy dx up here is equal to dy du times du dx. So if you look at this first one, this first one is going to give us, we can find du dx of this. So you're just going to find the derivative of this function, which is actually 3, because it'd be x times 3, and you reduce the power. And then over here, we're going to find the dy du, so the derivative of this function. So you would go 20 times the number in front, which would be 20, and then you got u, and you reduce the power by 19. So now that you have those two, you can then say that dy dx equals the du so it's going to equal dy du times the other one, du dx. So if we go and do that, we have so dy du was 20 u 19, and we're going to times it by du dx, which was 3. So then you end up with your answer for the derivative, we would be 60 u 19. Now obviously we don't want to have u in it, so now you substitute back what u is. Well, we know that u is actually 3x plus 4, so we'll put it like that, and we know it's to the power of 19. So there we have our derivative using the chain rule. Okay, so with this one, find the gradient of the curve, or the derivative, with the equation. So here we've got the equation y equals 16 over 3x squared plus 1. So we can't simplify or cross cancel down that like we have in previous questions. So we'll need to use the chain rule to find the gradient formula or the derivative, and then they want us to find the actual gradient at that point, so when x equals 1. So we need the formula for the gradient, so dy dx. So we're probably going to need to use the chain rule, so dy du times du dx. So what I'm going to do is I'm going to let u equal the 3x squared plus 1, and therefore my formula would be y equals 16 over u. Now we know we can also write that as y equals 16 u to the negative 1. So we'll do that so that we now can find du dx of this first equation. So it'd be 2 times 3, which is 6x, and reduce the power, which would be 1. And I can find dy du, which would be negative 16 u to the negative 2. And I now know that dy dx is when we times those two together. So I get negative 16 u to negative 2 times 6x. So I end up with negative 96x u to the negative 2. And then we can just pop in what u is, which we said was 3x squared plus 1 to the negative 2. Now, that could also be written, so dy dx, because we don't like to have negative powers, 96x over 3x squared plus 1 to the positive 2. Alright, so now they've asked me to find the gradient when x equals 1 on the graph. So n equals 1, so I'm going to sub that into, so dy dx, and we're going to put 1 into everything. So it'd be 3 times 1 squared plus 1. So we're never going to give you 1 manually. That's too hard for you. So we end up with negative 96 over 3 plus 1, which is 4. 4 squared is 16. Okay, so 16 goes into 96 6 times, so it ends up being negative 6. So the gradient at the point 1, 4 is 6. Okay, we're going to practice the chain rule one more time. So remember that dy dx with the chain rule is equal to du dx times dy du. So if I'm going to let what's inside, let 4x cubed minus 5x equal u. So therefore y would equal u to the power of negative 2. So if I find du dx, that will equal 3 times 4 is 12, 12x squared minus 5. And then if I find dy du, that's going to be negative 2u negative 3. So then we know when we've got to find the whole derivative, it's going to be dy du times du dx. So we end up with negative 2u negative 3 times 12x squared minus 5. So what we can then say is we might say it's put the negative 2 times 12x squared minus 5, and I'm going to put the u on the bottom and make it positive. So therefore I could say it's 12x squared minus 5, and now I'll sub the u back in, which was 4x cubed minus 5x to the power of 3. So there's a one, so you can find the derivative even if it's a big function like that.